Hey guys, welcome to the Tech Simplified TV. In today's episode, we will be talking about the impact of artificial intelligence in VLSI. We will talk about various zones of VLSI where the AI can provide awesome solutions. Wait, would you be happy or insecure when you think about intrusion of AI into the VLSI industry? Stay tuned till the end of this episode to know the answer. Welcome back. We are talking about the AI in VLSI. The question that is sticking in your mind, should I feel happy or insecure about AI entering into the VLSI industry? Well, you can be pessimistic that you feel you will become redundant by the intrusion of AI, or you can feel optimistic that AI will empower you as VLSI engineer. In both the cases, I will call you as an extremist. So let's have a view somewhere in between. This is called the realistic view. It is the rational way of welcoming any new thing. Now let's come to the fact in which areas of the VLSI the AI actually can fortify the industry. Can you answer which are the areas in VLSI that requires a lot of iteration on a single step again and again and again? Thus it slows down the productivity and the turnaround time. There are many such areas exist in the front end and the back end of the entire ASIC design flow, also known as the RTL to GDS2 flow. Front-end verification is a complex area in terms of coverage of every nook and corner. No matter how rigorous you do, you will still leave some leftover untouched scenarios. This might be a headache for any verification engineer. The AI can help in this particular sector using its intelligence to cover all the scenarios. Now, when we talk about VLSI, generally designs are incrementally changed over the time. This incremental change can be with respect to the fabrication technology. Like you are going from higher technology node towards the lower technology node. The incremental change can also come from changing some architecture of a particular design block for increasing the overall performance. This way, the incremental changes and their consequences may be tackled by the AI engine. It can use the past knowledge in form of known problem and solution scenarios, or it can access the knowledge base repository. From all these database, it can develop its own intelligence over the time. Let me tell you how an AI will work here before going any further. The setup of the engine will be different from our present software installation. The AI need loads of data samples because to have a broader perspective to develop its own intelligence. Hence, the AI has to operate from a cloud and not from a local desktop PC. This cloud obviously stay inside a single company and not like the real cloud in the sky which keeps floating around here and there. In a MNC, generally the designs are made through multi-site collaborative operations. So the cloud and the AI software together will have multiple feeds from the multiple human brains working across multiple sites. It will also have the access to the databases of all past cases of concerned groups working together in the same project. This way, the AI will learn how to deal with a difficult situation, and at the same time, it will be ready for the unprecedented situation lying in near or far future. However, human interventions will be much needed to segregate between the relevant or irrelevant suggestions from the AI engine. The next section I am talking about is the VLSI backend, where the criticality and the iterations are much more as compared to its front-end counterpart. This is because at this level we are entering into the layout. Now here the AI can play a good part based on the past experiences, whether it is coming from the knowledge base or it is coming from the various engineers who have worked on the cloud, as I have mentioned earlier. With the AI, issues and challenges in various stages of the PNR will be resolved at a faster pace. Rectification or preventive rectification for various physical verification faults will be tackled much faster. Now, at this stage, the intervention of a human being is a must because the design has to go on to silicon. And it's nothing like the software industry where we can release a software patch to tackle any red or yellow flag happening on the customer end. In VLSI industry, industry, we cannot release a patch on the final silicon chip already out in the consumer market. So you can understand that as a VLSI engineer, you are not in a threatened condition, because at the end of the day, the sanctity of the analysis or the correction made by the AI engine has to be doubly verified with human interpretation and intervention. The next stage impacted by AI is the static timing analysis. In a multi-million gate chip, there will be a lot of STA violations. Some will be false alarms. AI can easily root out these false alarms. Rest of the unnecessary what if then cases, the AI can simulate with its own brain. Rest of the multi-level necessary changes will be clearly presented by the AI engine towards the VLSI engineer. One more thing, IR drop, hotspot management, multi-PVT, multi-OCV layout verification will be like a breeze with the AI being in the VLSI arena. Now let's move our focus to other areas of the VLSI design where the AI will have impact. In analog design, simulation of the analog circuits require a lot of runtime in multiple days. Sometimes this covers a week or a month based on the design size. To some extent, these runtime challenges have been improved in recent times by usage of fast SPICE, accelerated SPICE or GPU enabled SPICE, etc. When we have a cloud and AI in the place for the analog VLSI industry, we will continue the analog simulations to the AI engine and the cloud together. The killer combination of this duo will have the access to all of the past cases, all their simulation data, all their problems and solutions. So having all that data bank in the brain, the AI engine will be able to simulate large analog designs in almost no times. Now let us focus on to the next area where the AI will have a major impact. This is none other than the standard cell design and characterization. The standard cell domain has a huge amount of manpower involved in the rigorous cell development and verification for the various views across multiple cell height, PVT, EDA vendor, etc. With the help of the AI, all of these can be streamlined with efficiency and lesser iteration. VLSI engineer working in the standard cell design and characterization domain will be very much happy to release one version of the entire standard cell library in a very short time. Any customization of the library as a part or as a whole for the specific customer will become much easier to cater. The next trending area that will have a huge impact is the analog mixed signal simulations. In this domain, the setup of analog and digital together itself is a cumbersome process. Sometimes this setup takes a long time because the fundamental mismatch between various digital and analog blocks inside the entire design. Mismatch of ports declaration is very common. Insertion of A to D or D to A and many such other boundary converters is a cumbersome process. The AI can take care of these things in a very easy way. As I already mentioned that the analog simulation will run faster once it will come under the hood of the AI. Obviously, the mixed signal simulation will finish in a wink of an eye. Well guys, I would like to conclude here. I have provided some links of the recent AI developments in the fields of VLSI in the description down below. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. Put your comments in the comment section down below, and bye for today.